Hi guys. Um, Apparently I didn't get didn't get audio the first time. So let's do this again. All right, I'll try to do this quickly. All right, so today I want to talk about the new flash, the flasher for the Foenix Jr. The reason I want to make a video is make sure that people understand how it works. So there's no confusion in 20 questions. I guess it's easier to make a video, 5 minutes video, to get people, to teach people than to answer questions and things don't work. All right. So yesterday I released a new load for the revision A of the F256 Jr. and it's the November 13 version. And this version, the MMU is programmed to boot from Flash. So if you install, you program your new load in your board, it's going to expect for you to get code into the upper region of the Flash so it can boot from it. However, the revision A doesn't have a jumper on the board to decide which configuration you want to start. And when I say configuration, I mean either boot from Flash or boot from RAM. And I will come back to how the MMU is organized later. So let's begin by talking about the way the application works. So as usual, you would have the connect. So you have to have a legitimate board connected on a legitimate serial port with the right drivers and everything. And then if it is connected and properly, well, in that case, it's since the chip is powered through the USB, then the board doesn't need to be on to be connected, to be recognized. But in order to program, of course, you need to power on your board. So power on your board. So normally mine is on COM3. I connect, everybody's happy. This drop-down menu is allowing you to do changes. Obviously when you boot and you have this application, this is the value of this menu. However, keep in mind, and I think this is something I didn't think the last time I recorded that video, is that let's say if you start from scratch, you power it on, the default value of the board is it's Flash, right? It boots in Flash. So when you change this here, for example, if I switch it to boot from RAM, from the moment you release the little tab and the value has changed, the command is sent right away. All right. Basically, if you push the reset on the board, it's going to boot from RAM. If you have nothing in RAM, it's going to not do anything. All right. However, it's possible that I might keep the loader in that configuration and power up the board, power down and power up the board. Then those are not in sync anymore. So you need to remind yourself to go back to Flash and to come back to RAM so the command can be sent again. Like for example, like I said, when you're sending the Flash, it sends one value and says, hey, now set up the MMU in RAM configuration or Flash configuration. But if you're in the RAM configuration and you boot up, again, then it will be resetted to Flash configuration. So the two are not the same. So you need to go back to Flash, which basically send the command, hey, be in Flash, but it's going to be already in Flash. And then you come back to RAM and say, hey, put it back to RAM. So keep that in mind. It's very important. So I'm not going to read the value and then set it up. I'm just sending the value out, saying be in that mode. So if you power it up, if you power up the board, might as well reboot the flasher. But anyway, the uploader. Anyway, so that's the first thing that is very important, that is very different. I mean, it was not there before, now it's there for the Junior. This is for revision A, any other product to come in the future, I suppose. There is a jumper for revision B, so it's going to be a jumper selection as opposed to be a software selection, because the USB will ignore it. The USB signal will be ignored because I would have to put another flag to say choose from this, and no. Okay. normally, as we've did in the past before, if you want, for example, you want to program something in Flash and RAM. So in RAM now. Okay, so I'm set up in RAM. I boot from RAM. So you can either boot from reset again or not, or you can just change it there and then sending your data, and then the CPU will reset and you should be fine. However, doing a manual reset is a good thing. This is something I need to add. I need to add a new command to reset everything as opposed to just the CPU. It's coming. All right, so normally, like if you use the flasher before, you know, you load your bin, it's loaded in RAM, you put the address it goes. So in that case, it goes into 8000, and then I just send it out, and it's going to be sent out in RAM, and it's going to be executed, right? Awesome. Now, let's say you want to program a flash sector, and this is a new thing. So now we're dealing with sectors. It's not like you're putting your code, you're flashing one big chunk, it's done. No, it's done and designed to do 8K sectors. So the new revision, November 13, is designed to do that. So since this one is too big, I'll use a smaller one. And so this is the knack, is that when you're programming a flash sector, you need to do it in, you need to download your code into 0, okay? Because the flasher will use the first 8K of RAM as a buffer, and this is where you place your code, okay? Not to be executed, to be flashed. The second thing you do, you choose a sector you want. So there's a lot of sectors, there's a lot of 8Ks. I mean, it's 512K, so there's a lot of them. But let's say you want to do the boot one. So this is the one that gets configured at the top of the MMU. So that's the last one, okay? So this is the one you want to program your kernel, your whatever you want on your unit. Then you click on flash here, of course, and then you just send binary. It asks you if you want to flash it, and then it's really quick. Doesn't take much. Now, the flash has been programmed. If you're still in boot from RAM, it's still going to boot from RAM. So if you want to see if it works, you go back to flash, and then you reflash, and your boards will start from flash. And then you can do your thing. But remember, every time you reset, you're going to reset in flash. So if you're developing an application, you might as well be in RAM and do all your development in RAM and then flash your thing. But it's up to you. So the key thing here is to remember that the destination when you want to flash a sector should be from 0 as opposed to be from wherever the address is when you're running in RAM. Okay? So that's it. When you're done, remove the flash thing here, and then you go back to your life and do whatever you want. And then the other sectors are the same. If you have a long string of things, of program you need to map into the MMU or transfer, it's up to you. This is really your prerogative at this point. Now, to finish this short video, we're already at 8 minutes. The MMU, the way the MMU is in the memory right now is basically, it's a block of memory. There's 32 bytes that are allocated for the configuration of RAM, and there's 32 bytes allocated for the flash configuration, which means that it's divided in 4 pages of 8 bytes. And when you are in RAM configuration, the configuration, when you initialize the board in RAM configuration, when you reset the values, well, the power on values, because the values don't change when you reset the board. In both configuration, it's a block of RAM. It doesn't change unless somebody clears it. I cannot clear it. It's a block of RAM. So fundamentally, when you boot up, the RAM value, the MMU values in the RAM configuration is, there's 8 segments. The values are 0, 1, 2, 3, 4, 5, 6, 7. And the 4 pages are exactly the same. 0, 1, 2, 3, 4, 5, 6, 7. That's why the 7th block of the RAM, which basically I'm using the 64 first K of the 256K of RAM at the bottom of the memory. And all 4 pages are all the same. It's not like 0, 1, 2, 3, 4, 5, 6, 7 in one page, and then all the rest are zeros. No, I've put them the same value. So if you switch from MMU pages to one to another after you boot up, you power up, you'll have the same results. Now, the flash, the 4 pages are configured 0, 1, 2, 3, 4, 5, 6, 7. No, 0, 1, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, and 7F, which is targeting the last block of flash, which is the block 3F. And this is the one that has been chosen to be filling the slot, the last slot of the memory space. Okay? And the 4 pages of that configuration is 0, 1, 2, 3, 4, 5, 6, 7, 6, 7F. Okay? All the 4 pages are the same. So this is when you power up. Now, if you run any software that modifies one or the other, because they're two separated things. So first of all, if you change on the flash or the uploader that you want to boot from flash to RAM, it's automatic. The page will be flipped. So whatever value was in the flash, it will be active, and whatever was in RAM will be kind of stored. It will be like not used anymore. But there's still the value that were last posted the last time you switched. And then you need to, so that means that anything that you're running from the moment you switch from RAM to flash will stop because the MMU setup will change. Now, if you're switching from flash to RAM because you want to do some work in RAM, that's fine. So you're going to do changes and you're going to run your software that will use the MMU. And it's possible that one software will want to boot and start something new. Keep in mind that for all the developers that are doing, please initialize your lookup table at the beginning. It's very important because if the system stays on for a long time, the value stays persistent. They always stays the same, which means that eventually and inevitably, if you go back to flash, those values will change again. Until you power up the system, those values will remain. Okay? So it's like the sprite sectors, the sprite registers in Wiki. When when you're starting, they're all zeros because, the block is 0. But if there's a game and you exit the game and you start a new game, then some sprites might stay there because if you don't clear your thing, they will be the same as they were before because they don't clear. Some registers are real registers, but in that case, it's a memory block. And when it's a memory block, nothing gets erased from application to application. MMU is the same. So, but you have to understand that when it boots, it's not just it's just not one value that changes in MMU. It's the whole MMU paging that changes, that's been switched. So in a way, it's a great way to keep your values from one to the other, although I don't know, maybe somebody will complain about this. But that's the way it is. Because I'm using a dual port memory, on one side it's a slow clock to modify it, and the other one is a fast clock. That was the easiest way to do it. All right? So this is very important to understand. Set up your MMU from the get-go. Make sure, don't assume that it's the way it should be. Just program it the way you want, and everybody shall be happy. So that's it, guys. That's what the F256 loader is. And I guess at some point, now the Foenix IDE is kind of supporting the Junior. We could probably import those changes in the flasher in the Foenix IDE as well. It's up to Daniel at this point. But yeah, so this is how it works. So hope it helps. And I will talk to you later, guys.